Today we're going to look a little bit more at factoring. Factoring a quadratic that has a leading coefficient of 1 is simple. All you have to think to yourself is what two numbers multiply to get my constant and add to get that middle number. Multiplies to get 4, adds to get 5. That's simple, right? We can do this quickly, easily, all that kind of stuff. Now, today we're going to look more at when our a value is greater than 1. When that thing is, like right here, all right? It's negative 2. I said absolute value of a is greater than 1. If it's a negative, you can always just factor out a negative. So don't worry about the negative. You always just factor it out. In fact, this one right here can be made easier by factoring out something in common. Not only can we bring out a negative, we can also bring out a 2. I'm going to factor out negative 2. Notice once I factored out a negative 2, this is the same quadratic I started with in the first problem, and we can now factor that quadratic the same way. The only difference is that negative 2 is in front, and it's going to stay in front. It stays there. It doesn't go away. Don't get rid of it. It's still there. Because when we factor, whatever we have at the end has to multiply together to get us what we have at the beginning. And this brings me to the last one. This last one right here, it has a 2 in front. There's a number greater than 1 as our leading coefficient. But we can't factor out a 2. And so this brings us to the point where we have to know how to deal with this. And this is going to be common in this course. This is going to come up. We have to know how to deal with it. You have to be confident, and you have to have the method that you want to use. I'm going to show you my favorite method, but I'm also going to show you a few others because there are so many ways to do this. You've been taught this before probably, and you know there's some way that you've seen. I'm going to try to show you as many ways as I can remember, but you have to pick one. So don't expect, whatever way that I end up doing on the board. It doesn't have to be the same way that you do it, but at the end of the problem, we have to have the same answers. They have to be it has to factor the same, and all these methods should get us the same answers. And if not, we have to be careful. We have to go back and figure out where we screwed up. All right, let's take a look here. Let me start with probably the most common way of doing this. Not the typical way that I go about doing it, but it's a pretty common way. The first thing we're probably always going to have to do, first, if there was any common factor, we pull that out first. We always look for common factors first. There's no common factor, so we don't have to worry about that. And that's always going to be true. Always look for a common factor first. But on most of these, we're going to have to multiply a times c. 2 times negative 21 AC for this problem is a negative 42. That's a super typical thing that we're going to have to do. We're going to have to be able to multiply a times c. Now, we're also going to typically have to think of two numbers that multiply to get negative 42 and add to get negative 11. So when you think of things that multiply to get 42, you probably think 6 times 7, but there's no combination of negative 6s and positive 7s that get us 11. It's not that. It's actually, you got it? You thought of it? It's actually negative 14 and positive 3. So, it doesn't have to instantly come to you, but you have to be able to find it. You have to be able to find it, and negative 14 times 3 is very reasonable to find. Very reasonable. So, what I'm going to do, this first method is going to be factor by grouping. We're going to set this up to be factored by grouping. And how I'm going to do that is I'm going to rewrite that middle term with the negative 14 and the 3. So 2x squared minus 14x plus 3x minus 21. We are just rewriting that middle term with the numbers we have. All we've done is just put some makeup on it. Just made it look a little nicer, okay? Maybe not nicer, but it's going to be easier to deal with because when we have 4 terms, we can factor by grouping. I can group the first 2 terms, I can group the second 2 terms, pull out what's in common, 2x, leaving us with x minus 7. What's in common here? A positive 3, leaving us with x minus 7. Notice the x minus 7s are the same, which means our factor by grouping succeeded. What's in front becomes a factor. What's left in the parentheses is the other factor. So there's our answer. This method is called factor by grouping. I'll write the answer down here. Because no matter what method we do, we should get that same answer, okay? Because this is what multiplies together to get us this. Remember that. That's what's going on. That was factor by grouping. Let me show you my favorite method. This is what I like to do, all right? It's negative 14 and 3. The method that I like to use is a little weird, but to me it's quick, and that's why I do this method. Because it's a 2x squared, I put a 2x in the front of both. I use the negative 14 and the positive 3. And then I'm always looking to reduce. Because we multiplied by 2 earlier in the problem, I'm going to try to divide by 2 now. I can divide this one entirely by 2, leaving me with x minus 7 and 2x plus 3. Dividing both of those by 2. Notice it got me the same thing, okay? It's a little weird. You have to remember that step of dividing, because if you leave this as 2x and 2x, notice 2x times 2x does not get us 2x squared. That would give us 4x squared. So if you forget that step, you're done. You have to be careful there. That's my method because it's quick, all right? And I can remember that step. I had some students show me this method recently. So again, it all starts with the AC, finding the 2 numbers that multiply and add to get the middle number. But theirs, kind of similar to the one we just did, instead of putting a 2 in front of both, we're going to do x minus 14, x plus 3. Okay, interesting. And then, because of that 2 in front, because there's a 2 in front, we're going to divide both those numbers by 2. Very strange, I know. If we can reduce, then we do. Notice right here, this is x minus 7, this is x plus 3 over 2. X minus 7, 8, we can kind of see where these numbers are lining up. We call this method the slip-and-slide method. We slipped the 2 up underneath the numbers. We reduced if we could. If we can't reduce, or even after we reduce, we slide that number. If there's a denominator, you slide that number in front of your variable. Once again, we've used the method and we've gotten our final answer. The last method I'm going to show you is the one that I've used the least in my life, that I can't, I don't like it at all, but if you like it and it gets you the right answer, I love it for you. All right, please use what method you like the best. I'm going to have to think extra hard with this because I really don't use it, and it is the box method. All right, the box method. the box method, we're going to use our 2x squared and our negative 21. In the other two boxes, we're going to use what we had that comprised the middle, which is our negative 14x and our positive, I don't even have to write the plus, a positive 3x. Okay? Now, we're looking for what's in common. Right here, what is in common between the negative 14x and the negative 21 is a negative 7. That's what's in common right here. In this row, what's in common is a negative 7. What has to multiply by negative 7 to get negative 21? A positive 3. Notice that positive 3 is also what's in common in this row right here. So these two things multiplied to get negative 3. Or these two things multiply to get negative 21. Sorry. Right here in this row, think about what's in common in these two terms. The only thing in common is an x. And what times x gives us 2x squared? That would be 2x. So when you go through each of these, the row-column combination, they should multiply to get what's in that box. Notice on the top we have 2x plus 3. And over here on this side we have x minus 7. Again, another method, another way to do this. I'm sure there's more methods out there, but I want to show you several. Pick which one you like. All right, I told you I don't like this one, but if it works for you, use it. All of these methods will work. Have to be careful. You have to remember to use your common factor at the beginning. I mean, that's always the first thing. So I mean, we're looking at factoring quadratics. When we look at things that are not quadratics, there's different methods, okay? But when you're factoring a quadratic, pull out your common factor first. If there's 3 terms, we can use one of these methods. And if these methods don't work, it doesn't factor at all. It's possible that a quadratic doesn't factor. But if it does, all these methods get us the same answer.